Hi everyone, Steve Harvill with Creative Ventures, and let me take just a second to say thank you for the incredible success we've seen around our Did You Know series. Most of those videos get shared across the internet and shared among companies with the different divisions in different locations, so we're really grateful for that. So let's start. I'm going to imagine many of you hated math, and I get it, I understand. The formulas and symbols of algebra confused you. You got stuck in triangle hell in geometry, and the derivatives of calculus befuddled you. And you probably thought to yourself, when am I ever going to use this stuff in my real life? Mathematics comes from the Greek word mathema. Mathema just means it's a model of knowledge. And its application is so important to just about everything that we do. I want to tell you a story about how the linear thinking of mathematics can be left for a counterintuitive approach, and how that perspective, that ability to move out of a linear element, can be so vital to your strategy and planning. So let's take an example, and let's use negative space. We're not really attuned to visually negative space. It's there all the time, but we don't think of it as very important. And I'll imagine that when you look at a FedEx logo, you probably don't notice the arrow that sits between the E and the X because it's contained in negative space. Negative space is similar to counterintuitive thinking. So that's the story for this round of Did You Know? During World War II, there were a lot of secret organizations that were working on problems. In England, you had the Ultra Group led by Alan Turing trying to solve the Enigma puzzle of German coding. In America, you had the Manhattan Project led by Dr. Robert Oppenheimer trying to split the atom for the use in the atomic bomb. But we had a lot of other ones out there too. One of them was called the Applied Mathematics Panel. And these were brilliant mathematicians sequestered in an apartment in Manhattan, New York, where they were looking at military math problems. The Army Air Force, which came before the Air Force as a separate division of the armed forces, would say, how far do I have to lead a fighter, machine gun fire, to catch an enemy fighter moving at such speed? Or how do I fire a torpedo more accurately when I have to deal with the shift in currents and the speed of the opposing boat and different temperature variations in the ocean? That's what they were working on. And sometimes this brilliant group of mathematicians would stumble upon something that they would sub out to another secret group. This secret group of mathematicians and statisticians was called the Statistical Research Group, and it was hidden at Columbia University. And this is where we meet Abraham Wald, a brilliant mathematician, Hungarian-born, also a brilliant statistician. In fact, universally thought of as the smartest guy in the room. Now, the Army Air Force had given him a problem. They needed reassurance in their approach to protecting planes based upon enemy anti-aircraft strike patterns, distribution patterns of damage to the planes. They were already embarking on what they were going to do. They were going to add additional armor to the different planes, including the B-17 Flying Fortress. This was the most accurate bomber in history. Not only was it accurate, it was unbelievably heavy and slow. It carried 5,000 pounds of ordnance in addition to its crew. And it was taking shots constantly. They had patterns of distribution mapped out on the bottom of the planes, so that when Abraham Wald got the information, the Air Force was just looking for confirmation. We're going to add armor along the bottom of the fuselage where the most strikes are in an effort to protect the plane. So Wald was taking a look at the B-17 and he said, stop. Immediately stop adding armor to the fuselage. You're adding it to the wrong place. And they said, what? You've seen the statistical information we've given you. You've seen the photographs and the distribution models. That's exactly where we need to add it. It's where the primary enemy anti-aircraft and fighter pilot strikes are that are damaging the planes. He said, you're wrong. You're not looking for the missing holes. And they went, what? He said, you're thinking incorrectly about this. You're looking at every plane that made it back. The planes that didn't make it back, well, they were struck in a different place. They were more likely struck on the engines, because it would only take one accurate shot to knock out an engine. And many times, a single shot to this engine also knocked out the other engine. And those planes never made it back. The payload was lost and the crew was lost. You're looking in the wrong spot. You need to be adding armor where the missing holes are. And this counterintuitive methodology of thinking ended up being credited with Andrew Wald saving thousands of airmen's lives as the Army Air Force switched from adding armor to the fuselage to adding armor to the engines, protecting the B-17s and many other aircraft based on Wald's counterintuitive negative space thinking. This is not a difficult thing to learn for you, and you should apply it to the strategies that you're using in the development of your new ideas. There's 3 things that you need to think about asking. What are we missing? Make a list of those things that maybe somebody in that group thinks that you're missing in the way you're looking at this strategy. What are our assumptions? What are we assuming about the market, about a new product launch, about a story case for marketing? What assumptions are we making? And are those assumptions justified? What are we missing? What are our assumptions? Are those assumptions justified? Add that 3-part filter to your strategy, and you'll be looking at separation and differentiation in a different way. What you'll be doing is you'll be discovering the missing holes. Thanks for listening. We can't wait to bring you a new episode of Did You Know? And we'll see you next time.